Alright guys, welcome to lesson 6, and in this lesson we're going to be looking at features of a class. And the first thing I want to do is to show you this sheet, and really and truly I want you to be focusing really on the column that says scores. All of these columns are going to be irrelevant for now. So the discussion in this lesson is centered around the column that shows the classes. Now I'm going to just put this to this side so we can all see those classes there. And actually, before we do that, I just want to point out that I'm going to call this here the first class, the second class, the third class, and the fourth class. All right. So if you hear me say the first class, I'm talking about 1 to 5, second class 6 to 10, third class 11 to 15, and etc. So our focus is discussing class features or features of a class, whichever terminology you want to use, that's fine. So I'm just going to put this to the right of the video so that you can see clearly all of those classes. All right, let's get into it. Okay, so the first class that we have there is 1 to 5, and this is our first class. Now we have used the terminology class, okay, to describe these. Now you can call it a class, you can call it a group, or you can call it a class interval. Now again, this here is referred to as a class. So we have several classes here. We have the first class being 1 to 5, second class being 6 to 10, third class being 11 to 15, and fourth class being 16 to 20. I could also say this group, second group, third group, fourth group. I could also say the first class interval, the second class interval, third class interval, and so on. So whenever you hear me use the term class, is the same thing as class interval or group. Now, more often than not, CXC focuses on these two. So if you hear me say class and you hear me say class interval, you know it's the same thing I'm talking about, okay? All right, so right away, we are understanding what is meant by class interval, group, and class. So we have those terminologies locked. Now, the next thing I want to focus on for this first class here is what we call class limits. Now, this here, this one, would be the lower class limit. So 1 would be the lower class limit for this class, and 5 would be the upper class limit. Okay, so this is referred to as a class or group or class interval. Each class or group or class interval has limits, has class limits. This here would be the lower class limit, and 5 would be the upper class limit for the first class. Now if I bring this back over here, if we're looking at the second class, what would be the lower class limit? The lower class limit for the second class would be 6, and the upper class limit would be 10. For the third class or class interval, the lower class limit would be 11, and the upper class limit would be 15, and so on and so on. So that's what we mean by class limits. Lower class limit, upper class limit. All right. So far we've discussed class, group, class interval, where this is a class, also called a group, also called a class interval. Each class or group or class interval has limits. This, we're talking about the first class. This 1 here would be the lower class limit, and this 5 here would be the upper class limit as it relates to the first class. Okay? All right, so we have that out of the way. Now, the next thing we want to talk about are class boundaries. Now, we're still looking at the first class, 1 to 5. Now, here's the thing. I know we have score over here, but let's say, for example, you are doing a survey on the height of plants, as we discussed in the last question, the heights of plants. Now, if I can bring this back here for a second, we're looking at the heights of plants, right? We discussed this in a previous video, so I can use this sheet. Now we have 1 class here, 2 class here, 3 class here. So we have 3 classes, or we have 1, 2, 3 groups, or we have 3 class intervals. So this is the first class interval, second class interval, third class interval, or first class, second class, third class. Now, for this first class, the lower class limit would be 1 and the upper class limit would be 10. For the second class, the lower class limit would be 11 and the upper class limit would be 20. Now, the reason why I put this sheet back is because I want to bring out a very important point so you can understand where I'm going with the terminology class boundaries. Now, here it is that we did a survey where somebody went ahead and measured the heights of 25 plants. Okay? Now, when you're measuring the heights of 25 plants, even though we have, 7 plants measured from 1 to 10, 13 plants measured from 11 to 25 plants measured from 21 to 30. Do you honestly think that when they were measuring the plants, every single time they measured one of these 25 plants, they got exactly 10 centimeter or 12 centimeter or 29 centimeter or 3 centimeter? No, that's impractical. So sometime when they measured, they got maybe 3.1 or 3.02 or 20.05 or 20.5 or some of those values. Now, when we get a little later on in the topic, we're going to be using these information to construct 3 very technical graphs. One is called a cumulative frequency curve, one is called a histogram, and one is called a frequency polygon. Now, those graphs are constructed to give you other information, all right? But we're not going to get into that today. Now, again, there's a reason why we're talking about class boundaries, or we need to mention class boundaries. As I said before, when they're measuring the heights of these plants, the heights are not going to be perfectly whole numbers. They're going to go into the decimals, like 3.01, 3.4, 3.9, etc. Now, the class boundaries, when we're constructing these graphs that you're going to learn a little later from now, the class boundaries provide more accurate reading because the class boundaries trap some of these values that would be in the decimal point range, all right? 3.1, 3.9, etc. So, what do we mean by class boundaries? No, it's very, very easy. This is the first class here. So I'm going to use a blue ink marker to just emphasize now. Now, let's pretend, even though this is scores, let's just come off scores for a second. Let's pretend that this represented the heights of plants, all right? Or better, let me use this one. This represent the height of plants. Now, I am sure when they measured some plants, they would have gotten maybe 10.1 or maybe 10.2. Or let's say that they didn't. Let's not say for sure that they got it. There's a possibility that it happened. So, in order to trap accurately those measurements, what we're going to do is take off 0.5 on this side and add 0.5 on this side. That's just a rule in terms of generating the class boundaries for these classes. So, the class boundaries for this class would be 0.5 and 10.5. And all that does is trap those values that are incrementally off the whole numbers. All right. So that being said, the class boundaries for the first class, 1 to 5. If we're talking about class boundaries now. So for here, we would have 0.5. So we're taking our 0.5 on this side. I just a rule, we take our 0.5. And we're adding that to that side, so it'll be 5.5. All right, now it wouldn't necessarily apply in this case of scores, because this would seem as if we're taking the scores of students, right? And it depends though on how the teacher is marking, because if the teacher can get 5.5 as a mark, then really and truly the class intervals would not lend to you trapping all the values, so it's better to use the class boundaries. Now the class boundaries make a little bit more sense when it come on to things like height and weight as opposed to scores, but still we can use the class boundaries because they're more accurate in trapping the values. It's a true reflection of the data anyway. You're going to see that when we get to the graphs, but what I want you to understand now is how to get the class boundaries. So if the class is 1 to 5, just take away 0.5 on this side and add 0.5 on that side. So it will be 0.5 to 5.5. Now, these are the class boundaries. Class boundaries for the first class, 1 to 5. And this guy here would be the lower class boundary. Okay, and what do you think this guy would be called? That's right, this would be called the upper class boundary. Okay, so the class boundaries, you'll only appreciate that more when you start to do the technical graphs that I'm talking about, but just accept this for now in how to determine the class boundaries based on a class. So let me ask you a question. For the second class, 6 to 10, what do you think the class boundaries would be? As I said before, let's take out 0.5 from the lower class limit and add the 0.5 to the upper class limit. So if the class is 6 to 10, then the lower class boundary would be 5.5 and the upper class boundary would be 10.5. All right, so you're just taking off 0.5 of one and adding 0.5 to the upper. All right, so what have we learned so far? What have we mentioned so far? This here is a group or a class interval. Each class interval has what we call class limits. This would be your lower class limit. This would be your upper class limit. Okay. Now each class or group or class interval can be represented using class boundaries, which would provide more accurate readings when we create a graph. So when we talk about graph creation, the class boundaries provide more accurate reading. So if the class or group or class interval is 1 to 5, then to get the class boundaries, just take away 0.5 from here and add it to here. So we have 0.5 to 5.5. Now when we've established the class boundaries, then this here would be the lower class boundary and this here would be the upper class boundary. So let's look at the third class here. What do you think the lower class boundary would be? It would be 10.5 and the upper class boundary would be 15.5. All right. So we've mentioned a couple of key things so far. All right. Now the next thing we want to discuss. So I'm just going to shift this a little bit and carry this over here. I want to be able to see as much as we can there. All right. So the next thing we want to talk about is something that you already know how to do or have a very good idea of doing, and that is what we call a class midpoint. So I'm going to put back the class here, all right, and we want to discuss now the class midpoint, and that's very simple. Class midpoint, all right, discussing the class midpoint now. To get the class midpoint, we just take this value and this value, add them together as we discussed before and divide by 2. So that will be 6 over 2, and the class midpoint for this class would be 3. So the class midpoint for the class 1 to 5 would be 3. What do you think The class midpoint would be for 6 to 10. You should know that already because we've done this a couple of times. So 6 plus 10 is 16 divided by 2, and that is going to be 8. So it's very simple to find the class midpoint. So far we've mentioned class, which is the same thing as group or class interval. We've mentioned class limits. We've mentioned lower class limit, upper class limit, class boundaries, lower class boundary, and upper class boundary. Now, there's one more thing to mention before we go, and this is going to be very, very important because this one, students make a lot of mistakes on. So, I left this one for last for good reason. So, I'm going to put this back here. Now, big question is this, and I'm just going to point it out here. I'm going to slide this back for a sec. And what you need to understand clearly is, I'm going to put an asterisk beside this one because students mess up this one all the time. And that is class width. Class width. And by the way, class width is also sometimes called class size. So whether they say class width or class size is the same thing. All right. Now, a lot of times students make the mistake of answering it this way when they're asked to find the class width or the class size. They say, oh, all right, 5 minus 1 is 4, and the class width is 4. Very, very, very wrong. Now, I'm just going to do this very, 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 very quickly and point this out so you don't make any mistakes. If you want to quickly determine the class width when you're looking at classes, simply subtract these two values. Whether these values or these values is going to be the same. 6 minus 1 is 5. 10 minus 1 is 5. Even if you do this, 11 minus 6 is 5. 15 minus 10 is 5. 16 minus 11 is 5. 20 minus 15 is 5. That's the class width. Okay? So a lot of times students subtract these two numbers and say, oh, that's the class width. No. To get the class width, just subtract these numbers here. Consecutive numbers coming on each other. So 6 minus 1 is 5, 11 minus 6 is 5, 16 minus 11 is 5, or 20 minus 15 is 5, 15 minus 10 is 5, 10 minus 5 is 5. That's what the class width is. But if you want the official formula for class width, it is upper class boundary minus lower class boundary. So, you remember when we discussed this? Here we go. Here's the upper class boundary. Here's a lower class boundary. So that would be 5.5 minus 0.5, which is equal to 5. So the class width for these groups would be 5, not 4. It would be 5. So if you want to quickly know to subtract these numbers here, right, and you get the class width immediately. So, gentlemen, in closing, you need to know, please review this video as many times as you want. You need to know what is meant by class or group or class interval. All of those are the same thing right there. You need to know what is meant by class limits. And if you know what class limits are, then you should know what the upper class limit is, and you should also know what the lower class limit is. And I need you guys to make proper notes. Also, you need to know what class boundaries are, and again, the significance of these are going to come up when you do graph work. And if you know what class boundaries are, you know what the upper class boundary is and the lower class boundary. Okay? Next thing you need to know is what class midpoint is. And that has been discussed several times before. And the next thing you need to know is how to find the class width, which is also called class size. So you need to know all of these terminologies in moving forward in statistics, all right, as were discussed. and I'll be throwing out some questions as well in the group. So I need you guys to review this video as often as you wish, and then feel free to ask questions if you're still not certain. We can always do a follow-up video. All right, I hope you found this video insightful, and I'll see you guys on the next video.